So hello viewers and welcome back to another video on networking. So in last video we have had a very good experimentation stuff with the NS3 on the simulation of DHCP, right? DHCP protocol, we have used NS3 to simulate that. And now in this video we'll take one step further with the NS3. So we'll have a look at the advanced scenarios where we'll take a look at the Wi-Fi channel simulation with the DHCP. So we'll create a Wi-Fi network with wireless channel helper or YENS channel helper, and we'll see how that plays around, and we'll observe the simulation there, and as well as we'll take a look at the simulation where we'll create multiple pools on the same DHCP server, just like when we have configured with the Cisco packet tracer. So we'll explore those parts in today's video without wasting much time. Let's get started. So first of all, we'll take a look at the file which is there here in our NSA simulations repository. So that I have cloned over here, and you can see under the DHCP folder we have three files. So first file, basic DHCP, that we have seen in the last video. In this video we'll take a look at this 2 and third file. So second file, DHCP Wi-Fi, that I have copied over here in the my first file, my first.cc file, which is inside the scratch folder, as you can see over here. And the entire file structure is mostly same from the first file. As the first file, compared to the first file, we have this print IP address function which will just print the IP addresses of the nodes. Then at the end of the simulation, from here you can see simulator.schedule. And let's start look at the main function from start. So the first step is to create the command line arguments, and they are like almost same from past file. We have n nodes, verbose, and tracing. And then step 1 is to create the node containers. So as you can see, we have AP nodes and STA nodes. Now here AP node means the access point nodes, which is used to create an access point in the Wi-Fi. And STA nodes are like stationary nodes. They can have mobility model other than the stationary or constant position, but just for our reference we have kept all the other nodes apart from the access point nodes in the separate node container, which is we are referring here as in STA nodes. And we are also grouping this kind of nodes. We'll have just one access point and all other nodes that we pass through the command line, or by default it is 2. So by default we'll have 3 nodes, one access point, and STA nodes are 2. And then we are grouping all the nodes together over here in the all nodes. Now we'll create a channel which is over here we'll configure Wi-Fi channel. So in last video we have used the CSMA channel. Now you can see that we are using the YENS Wi-Fi channel helper. That is the class that will be helpful when we are using the Wi-Fi channel. Now this is the default configuration for Wi-Fi channel. So the way we create point-to-point and CSMA channel, that is not same for Wi-Fi channel. It differs a little bit. So over here we are using the channel, then Wi-Fi MAC helper and Wi-Fi helper. So these are the three conditions that we things that we are initializing over here. We can also set the Wi-Fi standard with this option. You can just uncomment this and play around with the Wi-Fi standard that you want to keep for your simulation, and see the paired captures if anything differs or not. So that's then assignment for you. When you clone this NSA simulation stuff, you can just play around with this. I have kept this as a comment, so you can future for your references you can use this. Now step 3 is to configure devices. Now as you can see, the way we configure point-to-point devices and CSMA devices, that differs a little bit over here. So we set the MAC type specifically while creating the devices when we are using the Wi-Fi channel or wireless channel. So you can see here we pass physical, MAC, and nodes. So these are the three things that are created over here that we pass, right? Then access point, for access point also we have this kind of a simulation. Same steps for creating the devices. Now once we create the device, it is very important for us to configure the mobility for Wi-Fi if we are simulating Wi-Fi. wireless channel, right? So that's why I have created the mobility helper. And as you can see right now, we are using the random walk mobility model for stationary nodes and constant position mobility for access point. So that means access point will be constantly on the same position, while these two set all the other stationary nodes, they'll have random walk 2D mobility model. We can change the mobility model from here. For the reference, I have kept the constant acceleration mobility model. You can just uncomment and play around with the different mobility models if you want and see the simulation how they differs, right? That's why I have kept that as a comment. Now step 4 is to install the IP stack. That's why that's where we are using all the nodes, and we are installing the IP stack on all the nodes. Then it is now time to configure the DHCP server and DHCP client. So as you can see, in the last video, we have seen the DHCP server configuration. So that is followed over here also. So first we pass the node pointer, then the IP address of the node, which is in this case 10.1 over here. Then IP network ID, network mask, the start IP address, and the end IP address for the DHCP pool, and the gateway IP address for DHCP pool. So these are all the configuration that we have kept over here, and this is the start and stop time for the DHCP server. Now for all the clients, the configuration is same. We are just installing the DHCP clients on all the stationary nodes, and this is the start and stop time for that. So this much line of code will configure DHCP server and client on all the nodes. Whether you pass the command line argument or not, this code will take care of all the things. Then step 5, we are skipping this again because we don't have any node which requires manual IP configuration. Then step 6 is to configure the ping. This is not necessary, but just for our reference that whether we have configured correct DHCP server or not, IP address are correctly assigned or not, we are using this ping helper. Then last is to configure the simulation. So this is the simulation stop time. This line of code will run the function at particular time. Then again, this is the constant position mobility for the access point. And this line of codes are commented because you can see the logic that I have written over here. Basically, you can uncomment this and experiment around with this. Right now, we'll just keep it as a comment. And then we'll generate simulation files and packet capture files, and that's it. So let's see what will happen. We'll clear the terminal and we'll run my first file, right? So I already ran this file first, so that's why it didn't took any time, and you can see the output over here. And you can see one packet got failed and we have 25% packet lost out of 4 packets that we sent. And here are the node configuration. Now why this happened? Because we have the random walk 2D mobility model installed, which means nodes can randomly walk around anywhere in the canvas within this boundary of a rectangle. That means whenever the nodes are far away from the access point, at that time ping is not getting to the nodes. That's why we see the packet loss over here. And we can just see the simulation from NS3 from NetNM. So we can just open NetNM and we can go to sources. We can open the file name DHCP simulation Wi-Fi, and as you can see the node, we'll just zoom it a little bit. Yeah. So node 1 and 2 are here and node 0 is here. Now let's simulate this. And as you can see, these circles are there because we are simulating the Wi-Fi channel. So this circle indicates the range for the APs. That's it, nothing much. And as you can see, the nodes are taking random positions in simulation time. And these arrows that you are seeing over here, those are packet transfers that are happening here and there. And you can see basically the simulation, and you can get an idea that how this is going to play around. We'll close this one, and we can also observe the the packet capture files. So we can just open the file here are created with DHCP Wi-Fi 0. So this is the packet capture for access point. We can just filter output by DHCP, ARP and ICMP. So you can see these are the DHCP discover packet. Again, you can go and observe what are the fields that are carried over here. Offer, discover, offer, request, acknowledgement on all this, and at last you have an ARP. So that's actually it for the first file. Then for the second file, it is now interesting. So we have copied that third DHCP with multiple pools over here in the mysecond.cc. So now look at this file. So as you can see, pretty much the structure is same. Now the difference over here is that we have kept the DHCP server with multiple pools configuration. So as you can see, you can see the file structure. We are configuring the command line arguments, then we are creating the nodes, then we are creating the channels. Now here we are using CSMA and point-to-point channel. So the CSMA will contain multiple nodes, but there will be one point-to-point connection with the DHCP server. Now you can see we are creating the devices that is pretty much self-explanatory, and we are also utilizing the mobility helper to provide the mobility to the nodes, so that we don't need to see all those errors that come when we simulate this file. Now I have kept some uncommented lines over here. So basically you can just uncomment and see how the simulation will play around if we haven't commented this file. And then the main difference that you will see over here is that while configuring the DHCP server, you can see we are configuring the multiple pools. So this line of code will configure the pool for 192.168.10.1 network, and this line of code will configure the DHCP pool for 192.168.20.1. So basically we will have two networks, both are connected to DHCP server. And for first network, which is CSMA, so CSMA network, which means there will be multiple nodes which will request for the IP from this network 10.1, and there will be one point-to-point connection which is connected to DHCP server, which will request from this pool. And now we need to separately start the process and separately stop the process for this pool. And at last we'll configure the DHCP client for all the nodes, and we'll have a ping in this network 20.0 from this network. And at the end we will configure the simulations over here in the NetNM, and we'll see these things. So let's just go over here and let's see if we are able to properly run my second.cc file. As you can see, it is also ran immediately because we have ran this before. You can see we don't see any packet loss, and okay. So as you can see, these are the node 0, 1, 2, 3, and these are all the IP addresses. So you can see this node has two IP addresses, node 0, which is the DHCP server. So it has both the IP addresses in 10.0 network and 192.168.20.0 network. Now we have node 1 and 2 in the 192.168.10.0/24 network, which is CSMA channel. And we have this last node, which is 192.168.20.0/24 network. And as you can see, they are also assigned, they are all assigned IP address perfectly. So now we can just check the simulation first of all in the NetNM, and then we can observe the packet captures. So let's observe the file name DHCP simulation, DHCP simulation basic. So as you can see, this is 0th node is DHCP server, and this is the point-to-point connection, and these both nodes are CSMA in CSMA channel. So now let's simulate this. So as you can see, these are all the broadcast packets. These are DHCP requests, and this is also DHCP discover. This is also DHCP discover packet that are coming over here. And you can see the simulation how this plays out. Actually this got stopped, but let me play again. And after 15 seconds, we can see that this is ping over here. So these are all 4 packets that were ping from this node to this node. I can just show you again. So till 15. Okay. Now you can see these are all ping packets. So node number 1 is trying to ping to node number 3, and this is CSMA. So CSMA channel, that's why the packet flows to all the nodes, and this is point to point channel. And you can observe the simulation over here. You can also go into the packet flows to see how the packet flows is looking. And now we can also observe the packet capture files. So for that we need to open the file named DHCP simulation node. So open DHCP simulation node 0. So this is the DHCP client, sorry, DHCP server. So we'll filter by DHCP ERP and ICMP. And as you can see, these are the discover packets. So we can find the discover packet for, let's say we'll check offer packet. So this is offer for 10.2. This is offer for 10.3. And we should see the third offer. Okay, we are not seeing any third offer. DHCP request acknowledgement. Okay. Okay, never mind. But as you can see, we have this kind of ERP request going over here. Sorry, ERP request here, and then followed by the ping. So that concludes our whole DHCP simulation stuff in the NS3. We have seen 3 different scenarios where we have seen the basic DHCP simulation, where we have just configured the DHCP server and client in few of the nodes with the CSMA channel. Then we have seen that how we can configure the DHCP into Wi-Fi, and then we have seen that how we can configure the DHCP server with multiple pools. We can also try to simulate for the DHCP relays in the NS3, but it is not supported by NS3 by default, and we have to write the code on our own. That seems to be a little bit hard, but you can do that on your own also. And in all these 3 files, I have kept some lines uncommented. Sorry, some lines commented. You can basically uncomment those lines and see if those are basically variable fields that you can play around with. So that's it for today's video. I hope you have got the idea about how we can configure DHCP inside NS3, and overall DHCP, how the protocol is working, what are the packet captures, what are the packet formats for it, and how it works. And if you have any doubts, feel free to ping me in the comments, and I'll be happy to answer those questions. So that's it for today's video. We'll meet in the next one. Till then, keep learning and keep exploring.